Hello, this video is a pure repetition of things you have seen earlier for sure, but I just recall them just for the case you maybe forgot. So this one is about sine, cosine and Pythagorean identity. We will use several times, not too much, but at like 2 or 3 occasions we will talk about sine, cosine, and we will use Pythagorean identity. And this is why I would like to recall that the graph of a sine function is this green one here. You remember that this function is 2 pi periodic. It means that everything what happens between 0 and 2 pi repeats like endlessly. And cosine is, well, it's actually the same curve, but it's shifted like pi half in one direction. So it's well, so you see, so cosine of 0 is equal to 1, and cosine of pi half is equal to 0. So these graphs are probably very well known to you. And you also know that you can also depict cosine and sine in the unit circle. So, for example, if you have here in the unit circle means that the radius of the circle is equal to 1. This is why unit, and usually we place the center of this circle in the origin. So here you have the angle alpha between this radius and the positive x-axis. Then you know that the coordinates of this point here on the intersection between this radius and the circle are cosine of alpha and sine of alpha. And well, you remember how you first at school defined cosine and sine of an angle in a triangle. So here you have obviously this yellow triangle is a right triangle with a right angle here. So the cosine is this leg adjacent to the angle divided by the hypotenuse. But the length of hypotenuse is equal to 1. This means that this x-coordinate is simply equal to cosine of alpha. And the same reasoning for sine of alpha, which is defined as the length of the leg which is opposite to the angle, so it is this one, divided by the length of the hypotenuse, again 1. So this leg is equal to sine of alpha. And well, because you know this interpretation of cosine and sine as x and y coordinate of the points on the circle, then you know that in the first quadrant, so if our alpha angle is between 0 and pi half, then both cosine and sine are positive. Well, because in the first quadrant both x and y are positive. Then if our alpha was like between pi half and pi, then cosine is negative because x coordinate is negative in the second quadrant, and well, sine is positive because y coordinate is positive in the second quadrant. Then if our alpha is somewhere between pi and 3/2 of pi, then both cosine and sine are negative, because we then are in the third quadrant where both x and y coordinates are negative. And here, well, if our alpha is larger than 3/2 of pi, but smaller than 2 pi or 360 degrees, then the cosine is positive. Well, x is positive in the fourth quadrant, and sine is negative because y is negative in the fourth quadrant. So sometimes you will have to judge the sign of a cosine or sine of sine, and you can do this either from the graph if you want to, or from the unit circle if you find it like easier to do. It is you will get to the same result, of course, if you don't happen to draw the curve for sine in the wrong way. And well, the last thing is the Pythagorean identity. It is this one. If you have any number alpha in radians, then angle in radians, then you know that cosine squared of alpha plus sine square of alpha is always equal to 1. And this Pythagorean identity you simply prove from this right triangle and from the Pythagorean theorem. Well, cosine squared is this, well, cosine is this length. Sometimes it will be negative, but if you square it, it will just become positive, plus square of sine is equal to, well, squared hypotenuse, but it is just 1 because we are in the unit circle. So Pythagorean identity is like a direct consequence of Pythagorean theorem. And it's everything for now, and in the last video you will see the last piece of this general repetition and this preparation, like conceptual preparation for the entire course. Stay tuned. Bye bye.